Okay, for this video we're going to be talking about simplifying polynomials for Algebra 2 for us. That's section 4-1. Going to basically be describing what happens to the exponents. That's going to be our focus, along with the coefficients and the variables themselves. For multiplication, division, combining like terms, which is addition and subtraction, and then exponents like a power to a power rule. We'll talk about that too. So we're going through a quizizz that we had made for my class, and we're going to pick out just a couple to show kind of an example of each of these. The first one here, we have multiplication. We can tell that we have multiplication because we have two sets of parentheses next to each other with no other operation shown in between, no plus symbol or minus or anything like that. When we do this, we kind of break it down into steps and we kind of go piece by piece until we've covered everything in the multiplication. So the first thing I'm going to have us look at is the coefficients of each of these two pieces of this multiplication. So each of the terms that are being multiplied. So we're going to do the coefficients and multiply those together first. That's going to give me 6 times 4, which is 24. If I'm looking at the multiple choice answers, that rolls out half of them right away. The variable is going to stay the same, that base of x. Whenever I'm multiplying, that's going to stay as x. And then the exponent's going to change. So whenever you're multiplying things that have the same base, so x multiplied by x, for example, those exponents are going to add together. So a 7 and a 2 are going to become 9. So that would tell me it's this answer down here. I won't actually click or anything right now, but to kind of explain that addition right here, we need to think about what the 7th power and what the 2nd power actually means. So we'll go through this once. X to the 7th power really means that thing, the base, times itself 7 times. So that would be an x times x times x times x. We're going to have 7 of them. 1, 2, 3, 4, 5, 6, 7. And then we're multiplying by x squared, which is 2 more x's. And if I were to count and add each of these up, I would end up with 9 of them. So it's basically like I'm taking it apart and then pushing them all back together and regrouping. That's where the 9 comes from. Okay. So that's what we would do with multiplication. Let's look at division now, something like this. I have a separate video for longer division, so when there's multiple terms on the bottom, what do we do then? But we'll talk about what do we do when it's a monomial or a single term in the denominator or on bottom. So what we're going to end up with here is kind of piece by piece like the multiplication. I like to think of it as columns. So I'm going to break up the bases. So I see a 2 and then a z. I'm going to put a line in between those, and if I had another letter out here, I'd put a line in between those and I would keep going. Unlike multiplication, with division, the exponents are going to subtract from each other rather than add. So the base is going to stay the same again. So if you notice, I'm still going to have 2 raised to some power. But now I'm going to do 8 minus 6, which is going to give me 2. So I'm going to have 2 to the 2nd power when I simplify there. And then after that, I move to the right. I move to my next column. So I'm going to have z's. And I'm going to subtract those exponents. 10 minus 3 is 7. So I'm going to have z to the 7th power. The reasoning is pretty similar to what I showed. If I broke those apart and had 10 z's on top and 3 z's spread out on bottom, 3 of them would cancel out, leaving me with 7 of them. So it's the same kind of idea. And then if I look at my options here, that would be this one on the bottom right there. 2 squared times z to the 7th. If we don't have it in this problem, but if I would have ended up with, let's say, the 10 and the 3 were flip-flopped. When I did that second part, I would have ended up with z to the power of -7. What happens when you get a negative exponent is that it flips to the opposite part of a ratio. So we know at the beginning we got 2 squared. Technically, it'd be a 1 underneath it. But if I end up with something that is raised to a negative power, it then flips to the bottom, and its exponent changes sign, so it becomes positive. We would have ended up with something like this in that scenario. So I just wanted to cover that as well. Okay, let's move forward. Let's see what else we can find here. So if you notice, there's a couple different options, a couple examples of each. Let's look at something like this. So this is that power to a power example I talked about before. If I'm raising something that already has exponents to another exponent, what's going to happen? So I'm still doing it one at a time, one piece at a time, almost like distribution, except I'm not multiplying everything by 2. I'm raising everything to the second power, so it looks something like that. So we need to think about each piece. So first, the 3 squared is going to be a 9. And then when I take u squared to the second power, the rule there for the exponents is that they multiply. So 2 times 2 is 4. The reason being there is if I had u squared and I had 2 of them, they would totally they would break apart into 4 u's, which I'd bring back together, and they'd look like this. And then finally, v to the third power. Remember, those multiply when you have power to a power. I would end up with 6. Looks like I would end up with this choice here for power of a power. And then addition and subtraction is essentially combining like terms. I'm not even sure that we covered something like that here. Let me scroll back up and see. Okay, it looks like we didn't really have any on here, but what it would look like, we'll go off to the side, is if I asked you to do something like this. So let's say 2x squared plus 3x plus 1, and then in parentheses, minus or plus, it works pretty much the same way, negative 3x squared plus 4. How would we break that down? So we would want to do it piece by piece again. So the things that have like terms, so that's like the x squared terms would go together. The x terms would go together. However, it would be like combining with 0 since there's none over here. And then the constants would go together. So that'd be like the 1 and the 4. From there, let's flip back to our blue color, something like that. Let's think about our coefficients now. We have 2, and then I'm subtracting a negative. That's like I'm adding. So 2 plus 3 would give me a 5x squared. The variable and its exponent don't change when you're combining like terms, when you're adding or subtracting. Okay, next 3x minus 0 technically is just going to stay as 3x. And then finally, the constant's 1 minus a 4. That's going to give me a negative 3. None of these are like terms now, so that would be a final answer right there. Okay, hopefully this video helped. Give it a like if so. Leave a comment if there's something that you're still confused about or if there's something that this clarified. And feel free to subscribe if you haven't yet. All right, we'll see you guys.